So, good evening, everyone. Today we are going to continue with test method validation. So, the second most commonly used method for doing testing the repeat and reproducibility characteristics. And so, yesterday, said with test validation, and we saw the different methods: the cross gauge RNR and nested gauge RNR. So I hope everyone was able to download my tab and able to practice the exercise which we did. And I'll send you the date which you can use to do the studies. So please let me know if you have any difficulties in getting the data into the mini tab worksheet or the gauge analysis. Okay, we are going to continue with that. The second part being attribute agreement analysis, also called attribute DRNR. Okay, the same concept is going to be applicable to attribute. So in this case, we are measuring qualitative data attribute in nature. So basically, we are trying to say whether it meets the requirement or not. So it's pass or fail study. So in this case, the first step here is, as usual, measurement system analysis. So before you start your study, so you're going to assume that your measurement equipment itself is precise and everything is integrated. And second step here is determining the sample size. So a rough example which you're seeing right now in the screen in determination of sample size for the attribute gauge RNR. Thing can differ from company to company. So usually the sample size is going to be determined by the number of defects that you are going to be identifying in your attribute gauge RNR. So the number of defects. So basically, let's say that there is a product. A product, you are trying to find out whether the product has the length, it's green color. So that can be one type of defect. And the second defect being it should be free from debris or scrap. And third defect can be other defects that are applicable. So according to trying to find out how many defects you are trying to analyze in this particular study. So depending upon the number of defects, so you identify you are going to take samples accordingly. So for example, if in my study I'm just going to identify only one defect, so that defect being the color, so the output of the product should be blue in color. And if this is the case, then you're going to take 20 good samples and 20 bad samples. So take good samples, so 20 samples will be blue in color and 20 samples will be other random color. So that is the bad sample. So you'll be mixing them together when you are doing your study, and you'll be randomizing all the samples as we saw with respect to RNR, and the operators will determine that. If you are going to be having more than one defect, so accordingly in the table you are seeing how many samples you are going to take. So for example, if you are going to be identifying in addition to that color attribute, so you are going to identify whether there is some free from debris or it should be clear of any additional materials, I would say. So I will mark the attendance here. So I will take it at the end of the session. So that. Okay. Come back to attribute gauge RNR. Open an example. This is an example for an attribute TMV which was done. Okay, so you're seeing depending upon the number of defects that are going to be identified in this particular study. So for example, the defects are identified here. So the first one being burrs. So if the finished product should be like free from burrs. The second one is it should be free from dents, scratches or holes. So that are like another defects. So there are like 5 characteristics that they are identifying in this particular study. So depending upon that, you're going to go back and look at the table that the company has provided. So basically, there will be a procedure written. So you're going to go back and look at the number of defects that are going to be identified. So accordingly, let's say that you're going to be identifying 3 defects in your study. So you'll be taking 30 good samples and 10 bad samples for each type of defect. So in that, you will be getting 30 samples. So totally, there will be 60 samples your study. Okay, so we are going to be determining the sample size. And a couple of questions here. So variable gauge RNR consists of only nested and crossed gauge RNR. Actually, like this is the most common methods that I've been seeing, and also like in other companies or other in this industry. So these are the 2 types of study that will be for variable data, which is destructive and non-destructive. So study, so there is just only one, which is this attribute agreement analysis. Determine the sample size. Step is similar. So you're gonna like ask your colleagues or operators who's gonna be involved in the study to help you with the execution of this TMV. And you do like 2 trials or 3 trials. So what is the company's procedure here? So if minimum 2 is needed, then you're going to do 2 trials. If 3 is needed, then accordingly you're going to be doing the amount of trials. And then let's remember that in your gauge RNA study, your parts are going to be randomized in order to prevent the operators from remembering. So that is the goal here. And before you start your study, you want to like know the results in the case like what is the standard against which you're going to be like coming to. So like you have all these bad samples. So like how do you determine if this is like a bad sample or not? So you have to establish a standard for each and every sample. So for that, a standard will be requested for the study. So which will be like comparison, or you will be comparing to that standard. So how you determine the standard is, so usually there will be a skilled person in your company who can measure these parts and provide you the standard results. Or it will be like a group activity where you're going to be like meeting together and putting all the parts that are going to be used for the study, and will be like providing a response or coming to a conclusion whether this is a good part or a bad part. So that's how the standard is going to be determined. So before you start your study, this standard is going to be determined. And once you have all the information, you're going to start your execution. So it's the gauge RNR. So basically, you will be testing out all the samples in your first trial, and then the operator 2 comes in and he will be testing, or she will be testing all the samples that you tested. And the second trial will go on. And once you have all the results, you're going to copy and paste the data like from if you have put all your information in an Excel spreadsheet. You copy that information from the Excel spreadsheet into this mini tab session window, or in case the worksheet window, and also manually enter the data into mini tab. Okay, so we guys add study here. So I'm going to like show 2 different ways of putting this data and interpreting them. Okay, already created this project. Okay, I did is, so I just copied the results from one of the study and pasted them here. So this column that you're seeing here is the number of samples which I took for the study. So I took 30 samples. Okay. And I recruited two operators or two colleagues of mine. So basically so myself, John and Alan, so other two people. So we tested out all the samples. So these samples are going to be randomized. So for demo purpose, I just put it in continuous numbers. Usually it will be in random order. So I'm going to come in and I'm going to look at all the samples and I'm going to provide result. So basically you can say it as pass or fail or accept or reject. So the verbiage doesn't matter. So you're going to have any two verbiage. In this case, two verbiage. So either pass or fail or accept or reject. Or you can also say go, no go. So depending upon however you want to use the terminology here. So I done my first study and John comes in and he has done his first trial and Alan comes in, he has done his first trial. And I am going to repeat my second trial as well as the other people have repeated the second trial. Okay, so those are the columns that you are seeing from C2 to C7. And the last column which you are seeing right now is an expert decision, also called standard. This is nothing but standard or expert decision. So as I mentioned, this standard is usually you will be getting these results before you start your study from an expert from your company, or people get together and decide for each and every sample whether it's a good sample or a bad sample. So once you have all the information in this worksheet, the thing that you're going to do is you're going to analyze your data. So you're going to go to Stat, go to Query Tools, and on Attribute Agreement Analysis. Okay, so you are not going to go into Gauge Study option here. So you're going to come down and you will be seeing this Attribute Agreement Analysis. On that, once you click on that, this Attribute Agreement Analysis window opens, and you have two options here. So based upon how your data is arranged, so you will be using the first option or second option. So you'll be using the first option, in this case, the first thing. So you'll be only seeing like three columns. So basically, you will be selecting this option when you have all your data in all your results in one column. So in separating my results into 7 different columns here, so I'll be putting all my results under one column. And I'll be creating another column called appraiser, and I'll be putting either Prabhu, John, or Alan. So similar to what we saw in variable gauge RNR. So we did variable gauge RNR, so we just saw only 3 columns because all our data is going to be in those 3 columns. Going back to RNR, so you only see 3 columns because all my results are going to be in only one column rather than in separate columns. For attribute agreement analysis, in order for the user experience, so they have put in these 2 options. So either select the first option or the second option. In this case, all my data is in different columns. I am going to select a multiple column option. And when you select multiple column option, so you're going to click on that field, and you will be seeing all the columns that you have in the worksheet. So basically, this first thing you're going to be putting out all the appraisers, the results, the measurement data in the first column. All my measurement results are from C2 to C7. So what I'm going to do is, so basically, let's assume that this is empty here. Select here, and I'm going to select the columns which are in my C2 to C7. I'm going to select those columns from C2 to C7. I'm going to click on select, and all the columns got selected from Prabhu 1 or C2T to C7T. And the next columns are the number of appraisers here. Okay, let's usually get this. go to Stat here and click on Attribute Agreement Analysis. So you're going to clear the results that you have in the column. So from C2 to C7 in this case. And I must enter number of appraisers or operators used in this trial. So since we have used 3 people, I'm going to put 3. A number of trials. So I did 2 trials. So the user name is optional. So you can give it like whatever. So in this case, it's C. So I'm just giving the name here. And standard column. So if you have a standard column or standard result which you are going to compare to, so you're going to select that and select. So now we have selected all the necessary details, and you can go to options and like give your gauge RNR study a name, date, and who's performed by. So other information can be inputted here. So once completed all the necessary fields, you can click on OK. When you click on OK, so again you're going to be having 2 results. So one is the graphical result and the second one is the numerical result. So if you look at the graphical results and see like how to interpret the data here. Okay, in the first you will be seeing these 2 graphs by default. So we are seeing within appraiser graph and appraiser is a standard graph. So look at the within appraiser graph. So it's within appraiser graph, you're seeing like the red bar. So this red color line. So this red bar represents operators. So in this case, A, B, and C. And the X's that you're seeing right at the end of the red line, the X mark here, so indicates the confidence interval. So whether you have selected 99%, then it represents 99% confidence interval. If you selected 95, then it represents 95% confidence interval. So you can select that confidence interval in that attribute agreement analysis by going to options and changing to 90, 95, or 99. So depending upon the requirement, but the standard is going to be 95%. So select that you are saying 95% confidence interval. A dot in the middle, the blue color dot in the middle is the average percentage agreement for each operator. So for A, this is the average percentage of agreement, and for B is the average, and for C this is the average. What it means is, so basically if you look at, let's look at like operator A. So in this case, this blue color dot, so if you click on that blue color dot, you are seeing that the percentage is equal to 90. So what it means is, operator A agrees with himself on average of 90%. Okay? And if this person is to recorrect or redo the study again, so basically it could be like 95% confidence that the average is going to fall between these 2 values. So this is 73 point and this is 97 point. So basically if you're going to redo the study like with a different set of samples, so it could be 95% confidence that its true population or its true value is going to lie between these 2 X's. So this is the confidence interval limit here. This is what this represents. So say for operator B, so he's agreeing with himself like on an average of 53%. And if he is to do the study again, so he will be getting his true population or true value between these 2 ranges. So that is what the confidence interval is representing here. So the second graph is the appraiser versus standard. So you are seeing basically all your results are compared standard value. Okay, that is the appraiser versus standard. Okay, so a couple of questions here. So it is better to buy a higher confidence interval. So that confidence interval is not something like it's just your assurance basically. So if I say 95% here, so it means that 95% you can be confident that your value is going to lie between these two ranges, and the rest 5% it can lie outside these ranges. So if you're going to if you're going to increase this confidence interval, so basically this limit is going to increase because there is an uncertainty. You cannot be like, if you want to say that 99% value is going to lie between these two ranges, then your limit is going to expand. So let me put this by, let's test here. So let's note down these values for 95% confidence. So you're getting 73, the lower limit, and 97, your upper limit. If you want to like increase your confidence limit to 95%, being the interval, like you will be getting a wider interval. This is all about probabilities. It's like uncertainty. So if you be 99 or 100%, 100% is impossible. So 99%, then basically the limit is going to like expand. You can see there is an increase in the limit. So the lower limit now drops to 67 from 73, and the upper limit got here. So basically what it means is there is like, so it's all about like statistical that you are going to like calculate. So this means like if you're going to like, if to be 99% confidence, then your limit is obviously going to increase. And if you're going to like be 90% confidence, the limit is going to like decrease. So the industry standard is 95% confidence. So basically there is a whole lot of calculation behind like how you get these limits, the low limit and the upper limit. Okay, so just play around with the tool. So you can just range the confidence interval limit and try to play around. But the standard is always going to be 95%. So that is what you're going to be like expecting. For like a demo purpose, I just changed these values to 99, and you can change to 90, 80, or 70 and see how these limits are decreasing or increasing. Okay, so it's just like probability. So basically, what I am trying to say here is, so if this particular person, or if I want to like redo this study with like a different set of samples, I can be 95% confidence, or in this case, your true population value is going to lie between these two limits. So that is what this is representing. And like other details to this particular attribute agreement analysis. So what is the acceptance criteria? So what value should I get for me to pass the studies, which we will at. So basically, this red line is nothing but it's it's for each operator. So basically, X represents the confidence interval, and the blue color dot represents the average of Can everyone hear me? I don't know, like something happened here.
That's what I mean. The average for three different operators, A, B, C, are in different range. Does that make any difference?
Yeah, each operator did 2 trials, right? So in both the trials, they are comparing like what is the result for each and every sample. Case when you like take all the samples that was tested in both the trials for by operator A, so 90% of the time he got the results. For example, in the first trial he got like for sample 1 he like passed the sample. In the second trial also he passed the sample. So you take the average of all the samples, so that is what this represents. So as the operator B and C, they did not do well because in the first trial they got one value, and in the second trial they did not like got the same value. So they kind of interpreted the sample like instead of passing it they failed it, or instead of failing it they passed it. So that's what this represents. Okay, so this particular chart is just how they perform within themselves. So doing comparing the trial 1 and trial 2 data. This particular chart we are not comparing against the standard, which is the actual value. So that is what the second chart represents here. So in this case, this is a poor study here. So basically, since this is an attribute agreement analysis, you want your agreement at least to be above than greater than 90%. So there is an acceptance criteria behind that. So what this represents.
So in the second chart, appraiser versus standard, is standard the 100%?
So standard is the standard result. So like column in the worksheet, so which we got by taking the expert decision. So the expert or the group of people came together. So they analyze each and every sample, and this is the value that each operator should get. So this is like the standard for this particular test. So in the second chart, what is happening is all the results are compared against the standard, and there is a percentage given, like as in like how much percentage they are agreeing with respect to the standard. So, for example, operator A is agreeing with respect to the standard the same 90%. Operator B is agreeing to the standard 33%. Okay, with comparison to the standard. With comparison to himself, operator B is agreeing within 53%. As I mentioned in the first chart, we are not deciding whether it's right or wrong. So basically, on the data from each trials, whether they agree within themselves from trial 1 to trial 2. So that is what this is representing. Second one is what we are interested in. So how much they are agreeing with respect to the standard. So in this case, our result should be greater than 90 or 95%. So I would say the operator A did the study right. He was able to interpret the samples right. The operator B and C, they kind of failed. So to analyze what happened there. So basically, whether the operator did not know how to interpret the samples, or they not trained properly. So those kind of things will be like done before you do your study. If your results are not good, so you need to analyze the data here.
So there is no specific like arrow or something like that for standard?
Standard is always 100%. Okay, so this is the standard. Okay, so standard is the true value here. Okay.
Okay, that's what I meant. Okay, that's good. Thank you.
Yeah, that's the 100%. So for example, let's say that I will modify data for operator A, and let's assume that he's agreeing to the standard, like all his samples was right here. Play around with it. So basically, before you start your study, make sure that the operator is trained, and they should know like what is a bad part. So it should be trained on bad samples as well. So if you say that the dent or a hole it shouldn't be there in the sample, so that is a defect. So they should know like what is a dent, what is a hole, what is a scratch. So all things needs to be trained properly. Otherwise, you will not be getting your results right. So if I have to re-execute my study, so I have put operator A in this case, agree to standard 100%. So when you run the study again, so you will be getting the operator A to the standard 100% here. So you can see that I have changed the value. So in this case, what it means is operator A is like 100% is agreeing with the standard on average. So all results were right. So that is what this represents. So the target is going to be above 90%, okay, for all the operators. So that is going to be the target. So it's minimum 90 or 95%. The acceptance criteria is going to differ for different studies, but usually it should not be like less than 90%. This itself you can clearly like identify if the results passed or not. So in this case, I would say my gauge failed because to do an average, so like only operator A has been passed. His results were good, whereas B and C they did not. So failed the study here. And way of interpreting your data is from the numerical output window. So this is the numerical output window you are seeing. So you will be getting a breakdown of everything. So how much they are agreeing within themselves, that it within operators for both the trials. Case you are seeing that with respect to operator A, so he inspected 30 samples. So he agreed within himself on both trials like 100%. By 99% confidence interval, 95%, so you will have a limit. So if he has to redo the study with a different set of samples, his true value or true population is going to lie between this range. So that is what the confidence interval is representing. In the next set of data, each appraiser versus standard. So this case, it's comparing each operator versus standard. So again, getting the value. Next, tabular is comparing between appraisers and all appraisers versus standard. See, what you are going to be looking for is in the all appraisers versus standard. Basically, like you will be looking for this kappa value. This kappa value which you are seeing right now in the screen. So this kappa value, for each and every tabular you will find a kappa value. Kappa value for this all appraiser versus standard should be like greater than 0.9. Okay, so 0.9 is the acceptance criteria. So in certain studies it should be like 1. So 100% they should agree with respect to the standard. Because this is something like, since this is attribute in nature, so usually there is a more strict acceptance criteria. So you want your results to be like 100% or greater than 90%. So the acceptance criteria for the kappa value is going to be 0.9 or higher. Okay, again, just giving you the basic knowledge on how to survive. So given a TMV study, so basically you know you can execute and you will get the results. So I'm helping you with putting the results into the worksheet and interpreting the data. So there are like n number of TMVs that you will be like doing. So I will discuss a couple of TMVs examples here. So there will be like many TMV studies, and the ultimate goal is, so you are trying to prove whether kappa value or your acceptance criteria in this case should be like greater than 90 or 95%, or your kappa value should be greater than 0.9. So if you're looking at the percentage column, then this should be like greater than 90%, 95%. And looking at the kappa value, then this should be greater than 0.9. Okay, so 0.9 is the acceptance value. And I put a slide here saying what is the acceptance criteria. So acceptance criteria for kappa value is greater than 0.9 or higher. And this requirement, this is something like will be set on an individual basis depending upon the requirements of the application. Certain applications will require a kappa value of 1, or certain applications can be lower. And at the percent agreement column, then we want our percent agreement to equal to 95% or higher. So they are considered like meaning very good in nature. Again, this requirement are set on an individual basis. So there will be a systems like there will be applications where you need a percentage agreement of 100% is required. Depending upon the application, this acceptance criteria will be determined, and that will be like given to you what is the acceptance criteria for this particular study. So you coordinate with your quality lead or manager and you will get the necessary requirements and you will get the necessary information to prepare your TMV for attribute study. Either you can ask the operators or your colleagues in the company to help you with your attribute gauge RNR study. Okay, going back to the attribute. So this particular MV, they are testing out 5 different types of defects, and then they are taking like 32 good samples and 32 bad samples and start the study. So basically they will be training the operators or one who's going to do the study on how to identify the defect. So what is considered a defect? So for example, they will have a number of samples, so they'll train the operators. So hole or dent is something which will look like this. So if you see this particular case, then fail this particular sample. And so burr is something like the excess thing that was will be on the edge of the material due to like machining operations. So that is what. So if you see that, then you will fail the sample. So accordingly, all these things will be like trained for the operators. So they will not be training on the samples. So they will train on the characteristics of the defect. They will show you all the defects, how they look like, and then they will start the study here. So in this particular case, in this particular study, so you see that you're within an appraiser with a standard. So appraiser with a standard, so operator 1 or operator A, so he kind of agrees with respect to the standard, like around greater than 98%, which is very good, and the operator B 100%. And look at the numerical output for the kappa or the percentage information. We want our percentage to be greater than 95%, and your kappa value should be greater than 0.9 for each and every type of defect, or each and every type of passing criteria or a failing criteria. So here's all our kappa values you are seeing right now is greater than 0.9. So very good sign, and this particular TMV passed without any issues. Okay. Similar kind of TMV, or one more TMV which I can show you is inspection or label adherence. So what is this particular TMV is tested out is, so basically the operator should know like when to like what is a good label or a bad label. So whether if the label has this kind of information, then you should not paste a label onto the product. So mainly they will like test the operators on like what label is a passing or what label should fail. So in this case, so you're seeing right now, like, so if your label is clear without any anomalies, without any smudge or smear, then you can pass this particular label. And you have any like minor smearing or smudge here, so still the text are all visible and legible. So you pass this. Label is not fully adhered to the substrate. So it's not, that is okay, and still you're going to pass it. So these are all the passing criteria. And failing criteria is if your text is totally not able to like interpret, like it's not like visible at all, then you're going to fail this particular label. And if a part of the label is torn off or it's not there, then you're going to fail it. So this you're going to be training yourself and the operator, the one who's going to be helping you. And once train them, you will be like providing all these samples. Okay, so you'll be taking some samples, you'll be printing out and like making the necessary adjustments, and you're randomizing all the samples, and then will be used in your study. So that's what this TMV is about. So like, I want to know like the visual inspection for label adherence. The operator is able to like legibly like differentiate or distinguish, like they should be in a position to know like this label should not go into the product because it's not clear. So anyway, the customer will complain or will return the product. So for that purpose, this TV is executed. So it's all about like quality control. So test and validation is a process, or it's a documentation where you want to like control the quality of your product. So that is the ultimate goal here. Okay, so the second study that you will be doing, so this assignment is going to be like, I'm going to again provide, no, I'm not going to provide any data. So you use to make up your own data. Okay, so similar to what we saw in this session window, use either two trials or two operators or three operators. So just prepare a standard column. So take a number of samples and then manipulate your data and try to see like your percent agreement or kappa value meets the acceptance criteria. So I want one study to pass the criteria and the other study to fail, basically greater than 90 and less than 90 percentage. So any questions? Okay. So today's assignment, one of the assignments is going to be like doing this attribute agreement analysis. So in my example, I have taken three operators. Okay. So for your study, you can just take two operators and you can do two trials. Okay. So if you want to take more than two operators, you can do that. So it's up to you. So I just want a minimum of two operators and two trials. You can take any number of operators here. So you can take 4, 5, or 6. So it depends upon you. The number, the better the accurate results you will be getting. So that's the purpose. But since time consuming and you're going to need more samples and more cost is involved, so usually they will be stick to a minimum of 2 or 3 operators and minimum 2 trials. Yes, measurement data can be in accept or reject. You can also say pass or fail, or you can also so you can say pass or fail for data or reject, or also you can say like go or no go. So also another way of representing your results. Okay. So that said here, so that is the last slide of T for attribute gauge RNR. The final slide is just summarizing. So you're creating a TMV protocol and you will be assessing what type of data that you're going to be dealing with, whether it's a variable or attribute. And going to be variable, then whether it's a destructive or a non-destructive study. So destructive meaning your samples are going to be destroyed. So for example, you want to measure the force at which the sample gets right. So in that case, you will be applying certain amount of Newton force, the way the samples will get destroyed. So that is what destructive testing. Non-destructive, your samples can be reused. It's not going to be destroyed. And the third one is the attribute agreement analysis. So attribute, as I said, it's a pass or fail. So whether it's qualitative, so it's not like in a measurable quantity here. Just by looking at the samples, you will be saying whether it's a good sample or a bad sample. And written your protocol, it's going to be like up your project team members or your manager, and then you will start executing them and creating a final report or a test method validation report where you're going to like analyze your results. So you're going to like analyze all your results using Minitab or some kind of statistical software which is going to do the same functionality. But most of the cases, 99% you are going to be using Minitab because that has become an industry standard nowadays. So that's the reason I'm showing Minitab here. So using Minitab, you're going to do this analysis, interpret the data, and put them in your report, and finally get it signed off from your quality lead or your project team. Okay, no questions, then I will like to move on to the next topic here, which is called the process capability studies, measuring your process capability of your manufacturing process, or assessing your capability of your manufacturing process. Another important study which you will be doing, process validation engineer, so sometimes quality engineer might also be involved. So this process capability study, so as the name suggests, you are trying to find out whether your process is capable of producing conforming products which meets the end user or the user requirements or the specification limits. So that is the ultimate goal of process capability. So viewing your process capability, so you will be like measuring all the samples. So in this case, I'm talking about the product, the finished product, or any type of component which the company is manufacturing for each and every manufacturing process. So from your OQ study, from your PQ studies, so the end products are all your samples. So using this process capability study either in your OQ or PQ, or as well as like in any time during the manufacturing operations, you can do your process capability study here. So you compare your samples data with respect to your specification limits and see if it is within the specification limit or not. The capable manufacturing process, so it's the one where you can find all your measurements results from your samples. It's going to be inside the specification limit. Those are some of the definitions for a process capability study, or what is a process capability. And a process capability study, so it's a study which is a scientific and systemic procedure. Use certain control charts and other necessary statistical information or tools in order to detect and eliminate the unnatural causes of variation. And steady state of statistical control is reached. So it's completed, so you can kind of know whether there is any variation with respect to your specification limit. There is a variation, so you want to identify and try to minimize and bring the product into within that specification limit or the requirement range. Being said, so there are two types of study that you will be either performing. So the first one is the process performance, and the second one is the process potential study. Process performance study will be done over a longer period of time, and also it can include samples from a very unknown, like other number of factors. So what I mean here is, so for example, if you want to analyze whether your manufacturing process is capable or not, and to know on the longer run, so you'll be taking samples like say from today's production line, I will be getting some couple of samples, and tomorrow will be taking from different production line the same like product. There's a number of samples, and next week and the day after, then the next other week, and for about 4 or 5 weeks or like greater than that, you're going to be collecting samples from different production lines and production equipment, from different lots of materials or different shifts. So you are inducing a lot of unknown, or you're going to influence a lot of factors here, like you're including more variation to your study. It's the process performance study. So basically it's conducted over a longer period of time. You're going to have samples from factors to influence more process variation, meaning that from different production lines, from different lots of material, from different shifts, from different operators. So those are all the variation that you're going to be including. So this is going to be like predicting the overall future performance relative to the requirements. Like whether on a longer term it has the capability to all production lines. So I'm not talking about only one production line. So if the company is producing these products in 5 different production areas, so you'll be getting the samples and trying to analyze in the longer run whether it has the capability to meet the customer or the user requirement or not. Okay, so that is the first type. And the second type is the process potential. So you're going to be conducting the study instead of like for weeks or months, so just for days or like few days or a 1 day. So you're going to be conducting this study over a limited period of time, and you're not going to induce more variation as you induced for your performance study. In your process potential, so basically what you're going to be doing is you're going to be getting samples either from the same production line, from the same from the same raw materials, from the same equipment or operators. So there is not going to be like you'll be taking few samples for today from this production equipment, and tomorrow I'm going to take another few samples from another production equipment. So that is for process performance. So process potential is you are just trying to assess if it has the potential or not. So for the time being, for a limited for the time being, you will get to know whether it meets or it is your process conditions. In this case, your end results are meeting or within the specification limit or not. So that's what this process potential study, also called a feasibility study, before you can go on for a full-scale process performance study. So you will be doing the process potential first and then the process performance, because process potential, as I mentioned, shorter period of time, not more variation is going to be placed. So the ultimate goal is it's just whether it's a feasible process or not. Whereas process performance, on a longer run, you're going to be taking samples and analyzing your results. For this type of study, you're going to be using Minitab to like interpret your results. And results are going to be like in this format. It's going to be like a curve or this a normality curve. So this is the normal distribution curve or a bell curve. So this particular slide, you're seeing all the samples which was taken, and each and every sample was measured according to whatever the requirement is. So the value of all the samples or the process mean, also the target is 75, the upper control limit and the lower control limit. This thing is wrong. So USL and USL, so this is upper control limit, and next one is lower control limit, LCL or UCL. So these are requirements from your customer. So the customer would have said that I want my product to be within in this range. So they would have given us the tolerance. For example, the length of the water bottle that is being manufactured by the company should be like within 10 plus or minus 5 centimeter. So here the process width or the specification limit is the lower limit is 5 and the upper limit is 15. So this is what it's representing. Got all the samples, you have showed each and every sample, and you got your mean, and the mean you will be calculating your variance and standard deviation. And 6 sigma, also called 6 standard deviation, has become an industry standard. Process should be within like 6 standard deviation, in the sense like most of the requirement is going to be all manufacturing process should be within 6 standard deviation. That 6 sigma here represents. So from the center axis, so plus 3 on the right hand side and minus 3 on the left hand side. So that's what 6 sigma plus or minus 3 standard deviation. The slide, you will have accurate information of what I said. So for example, in this case, your target is 75, okay, and that's your limit, or that is your process mean here. So with respect to your process mean, so what you can see here is, so basically you are saying that, so like around 68% of my products that are being produced are within 1 standard deviation with respect to the process mean, and 2 or plus or minus 2 standard deviations. So what it says is, around 95% of my products that were analyzed are within 2 standard deviation from the target or from with respect to the process mean. And industry standard is 6 standard deviation or plus or minus 3 standard deviation. So 99.7% of the products that you're going to be producing is within with respect to the process mean or target. So that with respect to that, so around 99% of my samples or products are within that range. Okay. So you will have the specification limit, and you will be plotting this graph based on your sample mean, and you will be calculating the standard deviation, and you will be plotting plus or minus 3, so plus 3 and minus 3. And with respect to that, you want to have all your samples within that plus minus 3 standard deviation. That is the industry standard, as I mentioned. So again, it's not like going to true for every manufacturing process. Certain manufacturing process, you don't care about how the products, whether it's within the limit or not, because it might not be a critical impact to the quality of product. So for those processes, you will not like following up with the same pattern, like you want your results to be followed 6 standard deviation. So only those manufacturing process whose product output is going to be very crucial, which is like CQA parameter, like the critical to quality attribute. So for those manufacturing processes, the company will be like specifically targeting 6 standard deviation. Or sometimes like the customer might ask you to like provide the results showing that your particular qualification activity using when doing your OQ or PQ study. So you're doing your process capability analysis, and you'll be proving to your customer that our results are within this sigma or 6 standard deviation. Okay. Okay. In MAP, so you're going to be getting this output, so something similar to this. So from which you're going to interpret whether it meets your acceptance criteria or not. Okay. So how are you going to do this capability analysis? So what is the unit or the term that is going to be used to measure your capability studies? These statistical issues, basically CP, CPK, PP, and BPK, quantitative expressions which are going to be used to like measure to do your capability analysis. So when in representing whether it meets your criteria or not, you're going to be using these definitions, or in this case these terms CP, CK, and PP and PPK to express whether it meets your acceptance criteria or not. So C and CPK is going to be used for your short-term study, process potential. PP and PPK is going to be used for your long-term study, which is process performance. Okay, doing your process performance, you will be using or representing your results with respect to whether what is the value of PPK. So that is what the people are going to ask. So, example, here. Okay, you are saying this PPK acceptance criteria. This is what we are going to be doing that. So process validations, I just mentioned about writing and executing an OQ. So now we are going to like interpreting the results. So one of the results is going to be like process capability study. So you either doing your PPK or CPK. So when you do your OQ protocol, that is operational qualification, you will be like analyzing your CPK, and do your PQ protocol, you will be analyzing your PPK value. So it's just the terms that is different. So the overall what you call like the way that calculations or the result that is going to be represented. So it's just going to be almost same. So it's that in order to differentiate between short term and long term, so they have used this CPK and PPK value. So when you do a PQ protocol study, so you would be given the acceptance criteria. So you like your results and ensuring it meets acceptance criteria or not. So protocol, so this is a process capability chart that you will be putting together in Minitab and copying in your PQ report. So we will discuss this in a bit. So we will first cover the basics here, and we will do an example. Curve is going to look like, so bell-shaped curve. So with respect to in this slide, you're seeing the USL and LSL. So what is USL meaning? Upper specification limit and lower specification limit. So I mentioned you would get these limits from your, you'll be given that value. So we get the PQ protocol. So we set the criteria here. So the USL and LSL. So in this case, 0.43 plus or minus 0.005 inches. In this case, if you subtract 0.043 minus 0.005, you'll be getting a value. So that is going to be your lower specification limit. Upper specification limit is going to be like 0.043 plus 0.005. So you'll be getting that value. So that is going to be your upper specification limit. So that's how you get your upper and lower specification limit. Nothing but the mean of your process, also all the samples that you collected and measured. So you'll be calculating the process mean. The X bar represents the mean of the process. As the standard deviation, so it is sometimes represented by the Greek letter sigma or like just in S. So the standard deviation, and as I mentioned, the industry standard is going to be plus or minus 3 standard deviation. So that is what we are going to be focusing to. That is the specification spread limit, and this is the process spread. So with respect to your process spread, with respect to your specification limit or the specification spread, you're going to compare your process spread and determining whether how many samples are within a range or how many samples are going out of specification limit. So those kind of activities we are going to be discussing now. Okay. So the formula for all those CPK and CP is given here. CPK is nothing but upper specification limit minus lower specification limit divided by 6 standard deviation. Specification limit, as I mentioned, you already get from your requirement. And standard deviation is something you calculate from your mean, variance, and then you calculate your standard deviation. So again, you'll be getting your CP. And the CPK, this is going to be the minimum value of CPU or CPL. Formula is given. The only difference between CP or CPU, CPL is just you including your process mean in your calculation, which is called X bar. And in your CP, you are not going to include that process mean. So that is the only difference. So it is just going to say us whether it is within the specification limit or not. Whether it is within the LSL and USL or not. Your samples are lying. Where CPK is going to give you a more accurate information. So with respect to process mean, how well your samples are spaced, or with respect to targets, how well your samples are. What is the difference between CP and CPK? So CPK is what we are going to be interested in because that is more accurate estimation. So with respect to target or process means, how well my process has spread. So that is the CPK value is going to give us. Going into like more details here. So there's only a subtle difference between CPK and PK. So substitute this C in terms of P, the P, PPQ, PPL, and PPK formula is also remain the same. Okay. So when the formula for PP and PPK, the formula is exactly the same. Okay. The only difference is how the standard deviation is calculated between those two values, between two methods for CPK and PPK. So do your PPK analysis, you will be using your traditional way of calculating your standard deviation. So really you will be including all your samples and you will be calculating how normally we calculate the standard deviation. So it's going to give you a more accurate estimation. And CPK, we are not going to use the traditional method of calculating the standard deviation. We are going to be using an estimate method. So that estimate method is, so basically you will be estimating the standard deviation value that's to be substituted in the formula using the range bar or the S bar chart. So go into detail like what is range bar. We already discussed that is a range chart, and bar is standard deviation chart. So you're having these two charts in your when you do your capability analysis. And from those charts, you will be like using that value to include in your standard deviation. Why it is different is, so as I mentioned, process potential, also the CPK. So this is not going to include more variation to your process. The ultimate goal of doing process potential is it's like a feasibility study. Trying to like see whether our process is feasible or not. Okay, so that is what the goal here is. As PPK, you are trying to prove how well your process is performing right now. So this is a longer term study, so you will be like having more accurate representation. So that's the reason you will be like using the actual way of calculating standard deviation in your PPK, and CPK you will be using an estimate method of using your getting your standard deviation. In an ideal condition, if your CPK and PPK can be like equal together, so your manufacturing process, your feasibility study, and how well your manufacturing process is performing right now. So if they are very good, then you will have the CPK equal to PPK. So that can happen. But usually you will not see CPK equal to PPK. So there is going to be like a much difference. As I mentioned, so CPK is just only few variation, just only from one production equipment in this case for a short hours or short period of time. Whereas PPK, you are including more variation and more accurate estimate. You will know like how well your manufacturing processes or manufacturing operations run. So with further ado, so we will discuss the next slide. What is the acceptance criteria? To do this calculation, so when you plug in the values for your USL, LSL, process mean, and standard deviation, you're going to get some value for your CPK and PPK. So what is the value which I wanted to have, or what is the industry standard? So again, the industry standard is there, but depending upon your manufacturing process, whether that output of manufacturing process, whether it is critical to the quality of the finished product or other components. So depending on that, the CPK or PPK value might differ. Okay. So the industry standard is 1.33 for both CPK and PPK. So in this case, what this particular chart is saying is, so you have a CPK value of 1.33. So when you substitute your values in that formula, so if you get this value in this range, so it means that you're going to be producing only 63 defective products out of a million products that you're going to manufacture. Okay, so if I'm going to manufacture like a million product, 10 lakhs product, Out of that, only 64 products are going to be defective products, meaning that they are not going to fall within the specification limit. So that's what this represents, and that's the industry standard here. So the better the number, the higher the number, the better your manufacturing process. So if you have a CPK value of 2, that means like it's almost like you're producing 0 non-conforming products. Everything is within a specific limit or within the range. Okay, so that's what this chart is representing. So the defective rate and your CPK value. And so we are going to be targeting for greater than 1. Okay, so usually what happens is we want your CPK value to be greater than 1. It's very, very difficult to have you to get a CPK value of 1.33 in a real scenario. Actually, the industry or the people are going to be targeting for greater than 1 or like at least greater than 0.8 or 0.7. So sometimes depending upon the risk involved here. But you should want your CPK value to be greater than 1. So remember that. Industry standard is 1.33. And what it means is the last column will say like how many non-conforming products per million products that you're going to manufacture. So that's what this value is going to be referring to with respect to the defective rate. So let us look at an example and see if we can differentiate between.
Ask you please the slide before the chart, the table that you just showed us. Okay, the non-conforming the PM, the non-conforming TPM, that's the effective number of per million, right?
That's effective number of products that
yes.
you're going to produce. Yes.
All right. Thank you very much.
Okay, look at a couple of scenarios here so that you have a better understanding of how it relates to the CPK number. So let's take the first scenario. In this particular case, you are seeing that your customer expectation, which is your specification limit, and your voice of the process. So your voice of the process is like what your results are. So you took a number of samples and you measured them, and that is representing your voice of the process. Basically, if you're going to be having something like this, and if you basically your CPK value is going to be greater than 1.33 in this particular case. So the graph is going to look something like this. So that means definitely you are going to be having a CPK value greater than 1.33. So what it means is you have a very highly capable process. So you want to like maintain the same way of doing things. Then you want to be like producing only 64 non-conforming products out of a million product that you're going to manufacture. That is what this particular slide is saying. And as I mentioned, greater than 1.33 or greater than 1.33 is considered an industry benchmark. This means that your process is contained within like a number of standard deviations. So in this case, 4 standard deviation, or in this case 1.33, meaning your sigma value, which is the standard deviation. So this is going to be within 4 standard deviation. But in ideal condition, that is not possible. So that's why we are going to focus for 6 standard deviation. In this case, CASA minus 3 in this case. So that's why I said you want your CPK value to be greater than 1. So that is what we are going to be targeting to, because it's very difficult to achieve this CPK of 1.33. So even though it says industry standard, but most of the time you're going to be dealing with within that range, greater than 1. Well, this is another case where you are saying that this process is almost on top of your specification limit. Okay, what it means is it is a barely capable process. So since it is on top of the specification limit, future you cannot be sure that it will be remain the same that we are seeing right now. So there is a greater chance that it might slip to the left or right. If you shift to the left, so basically it is going to go outside the specification limit and you're going to produce more non-conforming product. So in this case, what it means is, so in this case you're going to produce at least between 64 to like 2700 or 3000 non-conforming products. And to keep an eye on this particular process, because in the future, if the process mean is going to move to the left or right, a significant portion of your product will start falling outside the specification limit, and you need to monitor this process very closely. What this example is telling us. So, and next one is your another case. Clearly your process is outside the specification limit, and directly you can say that this is going to be lesser than 1. What it means is it is going to produce more non-conforming product, and it's impossible for the current process to meet the specification, even if you want, if you're going to bring it into statistical control. Because like again, as I said, so it's definitely it's obviously outside the limit, so you definitely want to like look at basics of like you want to like look at your find the root cause of this particular issue. So what is the particular issue about, whether it's about the way the manufacturing is operation or the process input range, the material. So whatever the root cause is, you will need to try to identify the root cause and try to fix it immediately before you can go to the point of producing capable results. Again, it's similar to case 3. So in this case, the difference is one half of your product process is like within the limit, and the other half is going outside. So again, this is not a capable process. The target is also like shifting from with respect to your process mean. So you want to like do analysis and try to fix the process and bring them into like a control state before you can do your process capability analysis.
I'll ask you one question. In this graph, the mean X represents what exactly? That's the
So this X represents your mean of all the samples. Okay, so yeah, I have taken 100 samples and I have measured each and every sample, and do your average, you're going to get a mean of that, and that is what this X is representing. This target is representing your actual customer requirement. So, for example, like again, I'm going to go to the same example. Let's say that your customer requirement is plus or minus 10 plus or minus 2 centimeters. Okay, per control limit is going to be, for specification limit is going to be 2, and your specification limit is going to be 8. Okay, so this is a range that the customer you can your product can fall into. Okay, that doesn't mean that you are going to be producing only products at 8 centimeter or 12 centimeter. Actual target is going to be 10 meter. And only when you do your process capability analysis, this target must be equal to the process mean. So process mean is represented by that X. So that is what the X represents. So if that process is not equivalent to the process mean, then definitely there is a wrong. So you need to like improve your process. In the previous studies, in the previous cases, assumed that the X bar is equivalent to the target. Okay. So in this case, we assume the target is equivalent to the process mean. So we did not do anything because it met the process mean met the target. Whereas in the last case, it fall very very far behind the target, You need to like significantly work on this process improvement and try to bring your process mean into the target range. Something your requirement which you will be given, and your process mean is something you get from your actual execution of your all your samples. Measuring all your samples, you'll be getting the process mean. In a good manufacturing process conditions, your target and your process mean will be very close to each other. So at least subtle difference will be there, but almost it will be close to each other. If it's far away, then you need to work on that and try to find root cause investigation and try to get to the root cause of the problem and try to fix the problem before you can redo this capability study again. Okay, so before proceed slide here. So it is about how to do this process capability analysis. So now, so far we have seen what is process capability and what are the different types of studies that you will be involved in and different ways of measuring them. So the CPK and PPK. So CPK is for short-term or process potential and PPK is for process performance or long-term study. And what is the difference between CPK and PPK? It's just the way the standard deviation is calculated between CPK and PPK. Other than that, the formula is going to remain the same. Another thing is what is the industry standard value we saw and what that value represents. So it represents that you're going to produce this many non-conforming product out of 1 million products that you're going to manufacture. And we will look at the steps involved in doing your process capability analysis. So process capability analysis, you're going to make sure that your measurement system is good enough. It's a valid and acceptable measurement system. And it's recommended on the, it's basically like you will be doing a TMV test method validation usually on the measurement system before you can use it in your study. So that's what we saw in the test method validation. So a gauge RNA study can be done on this measurement system if that particular measurement system results is going to be like very crucial to the quality of the product. This case here, so make sure that a valid and acceptable measurement system analysis is done before start collecting your data for your study. And step here is determine the process capability study that you're going to be doing. So as only two capability studies that will be involved, the process potential or process performance. So determine like what is the study that you're going to be involved in. And process potential is usually done in your OQ and process performance is done in your PQ. Because when you're doing your OQ, writing and executing your validation, like operation qualification, it's just going to be like testing out one production equipment using like same lot of material or same raw materials. Whereas in your PQ study, you'll be using like multiple equipments, multiple operators, multiple production lines. So you'll be including that variation. So then usually your PQ protocol will be referred to as, like here you will be doing the process performance, and in your OQ you will be doing the process potential. But that is not always true. So sometimes outside of your OQ or PQ, so you'll be doing your process capability analysis in general to find out how well your manufacturing production is going on, doing your process performance. An important thing that you're going to determine what are the key process inputs. Okay, so that is what the critical process parameters which we discussed. So which process parameters should be included in your when doing your OQ or PQ? Because you're trying to select only those parameters which is going to have an impact on the quality of the product. So accordingly, you are going to try to like identify and control these key inputs or key process parameters, and that's the way to do it. If you're going to select like other parameters which doesn't make any sense, then it's obviously your capability metrics or your results is not going to be not meaningful. So the third step here is determine which key process inputs parameters are going to be chosen for your study. Step here is you're going to determine the sample size for your process capability, in this case process potential and process performance. So the number that you're seeing right now, so this is just a random number, so this is not always the case. But one thing that true is, in your process potential, you will be taking consecutive samples. You're going to be taking like few samples today and few samples tomorrow. So you're going to take consecutive samples from the same production equipment on the same hour. So you will be getting consecutive samples, and that is what you will be testing out in your process potential. Process performance study, you're taking subgroups of data collected over a period of time. So say subgroups data, each subgroup is going to have a few number of samples. Say that if you have 25 subgroups, so each subgroup is going to have 5 or 10 samples depending upon how many number of samples you are going to choose. Subgroup 1 would be taken in the morning shift today, subgroup 2 would be taken in the afternoon shift, subgroup 3, those samples will be taken in the evening shift. Similarly, 4, 5, and 6 will be taken over the next week or the next days or next month. So that is what the subgroups data is representing. And in your process performance, you're going to be using subgroups. A minimum of 25 to 50 is said here, but that is going to be difficult. Usually they will take anywhere from 10 to 15 or 5 to 10 or depending upon like the situation. So they will choose the subgroup for process performance study. And the next step you're going to do is you're going to collect your data. So data collection will be done. You're going to use Excel spreadsheet or some kind of a data collecting template. We're going to like collect the information, and you're going to evaluate certain criteria before you can start your capability analysis. And the two criteria is very, very, very important. So these are two things that you need to definitely check before you start your process capability analysis. And this like standard interview question. So what are the assumptions or what are the things that you check before you start your process capability analysis? The first that you're going to be checking is whether your process is stable or not. So you will be performing a stability assessment. So the reason for performing the stability assessment is, so you from this assessment you will get to know whether your process is stable or not. If it is not stable, then it's not going to be meaningful for you to do your process capability analysis and moving forward. So stability should be established here. Depending upon what type of study you are doing, you're going to be using a different control charts. So as I mentioned earlier, control charts, I sent a video link. So we have looked at the video link. So you know like what are control charts and the different control charts which are represented here. So potential study, which is like cognitive data, you're going to be using this chart for this chart for individuals, also called individual moving range. And if you're going to be doing your performance study, you're going to be using variable charts for subgroups. XR range or standard deviation chart. So from these charts, you're going to be analyzing and trying to see if your data is stable, if your process is stable. Based on your data, you're going to analyze whether your process is stable or not. Okay, the first assumption or the first thing that you're going to check. And second thing that you're going to check is the normality of the process, the data here. So you want your data to be normally distributed. So that is usually bill-shaped curve. So in the normal distribution, so when you do the analysis, again, I will show you like on how to do each and every analysis now. So we like doing the normality test, and you will be getting this p-value or probability value. So this value should be like greater than 0.05 in order for you to like accept or try to say that your data behaves normally. And the p-value is less than 0.05. So sometimes it might be acceptable depending upon what manufacturing operation you are testing on. If your product is not maybe a critical to the quality or it's not a very high risk, then there might like certain things that even if your normality is to or less than 0.05, so sometimes they might accept under certain circumstances. But usually it's going to be like greater than 0.05 p-value, and that means your data behaves normally. So that is the second analysis or the second thing that you're going to check before you do your normality. So before you start your analysis. So once you have find out your process is stable and your results data behaves normally, then you start your capability analysis and do your whether it's process potential or process performance. So depending upon that, you're going to be doing the capability analysis and getting the results. So interpreting the results and documenting the capability results. So that we will discuss now. Okay, so before I proceed forward, we will 5-minute break. Okay, so I'm just going to mute myself here. So we'll again convene at 45, around 6:45. Okay, so when we come back, we will look at how to do this analysis in Minitab. So I'm going to briefly explain you how to do the stability assessment, the normality, and the capability analysis. Right, so evening again, so let's assume. So the first thing that you're going to do is doing the trying to find out the stability of your process. So that is the first step which we discussed. On that, as I mentioned, you're going to use control charts. So click on Start, Control Charts, and when you click on Variable Charts for subgroup or Variable Charts for individual, so now select that option, and when you click on that, you have to select like which columns your data is in. So for demo purpose, I've already created a project here, so which we will use it. So say that you're going to be like calculating your stable assessment for individuals. So in this case, let's say that I want to just calculate my solve in like column number 1. So assume that there is only one column here, so you have all your information in column number 1. Like that, you will be getting the individual moving range graph, which is gonna give you whether it's within the limit or not. Okay, so the green color line represents the average and the upper control limit and the lower control limit. And there is a certain way of calculating this. But what we're expecting is, so we want to be like within the range. So that is what this particular chart is representing. So I'm going to explain like how you get each and every point here. So I asked you to look at the video. So if you have looked at the video, so you know like how the symbols are put here. And what is the individual value is represented in the first chart, and the moving range is nothing but the difference between the first two samples. That will be like plotted here in the second chart. So that is what the individual or moving range chart is going to give us. And this particular chart is going to be used if you're going to be doing your process study, which is going to have consecutive data. So it is going to have just only one subgroup, meaning that only consecutive samples are going to be involved in your process potential. So similarly, if you're going to be using process, if you're doing process performance, you're going to be having subgroups of data. So when you have subgroups of data, so in this case, I have like 10 different subgroups. So assume that I have 10 subgroups here. So from each day, I have taken a different number of samples. So I use each option, whether all my observations or all my data is in one column or all my observations for group or in one row of column. So just select which how the information you entered into the worksheet. So you are gonna sorry about switch columns here and then add subgroup size and just on OK. You just did the wrong way. I'm sorry about that. After the other options where you have all your information spread across the different groups. So this is only if you have all your information in the Okay. See the analysis done for all the subgroups. So there's one chart. So basically, the first chart is representing the sample mean, and the second chart is the sample range. So sample mean you are seeing for each and every day. Okay, for example, day 1. So what is your average mean here? And for day 3, similarly for all the 10 days, you are getting the average of all your cells, and that is plotted against here. And this gives you a good way of how your sample, your process mean, or in this case, your mean of the samples are differing from each production day. Okay, so from this, you can have a better understanding. And if your value is something very high, so it means that production day, the samples did not meet the requirement. If it's like outside the limit, you can easily identify that and try to look at if there are any deviations or things. So you are trying to find out the root cause and try to bring the process in a statistical state of control before you can proceed to the next step here. So, so that is the first step. So, just like if you are going to be doing your OQ and PQ study, actually you're going to directly go and do your process capability analysis. But in general, these are the two steps that you need to do, like the stability assessment and your normality assessment. So only after that the process capability assessment will be done. But again, if you are very sure enough that your manufacturing process is good, so you know that you're assuming that the process is stable and your data is normally distributed, you will directly go and do your process capability analysis. Okay, things can happen. So depending upon how your quality or your process validation engineers wanted you to do, so accordingly you're going to use the tab or other statistical tool to plot the control charts, and from the control charts you can determine if it is a stable process or not. Another way is your normality study. Basically simple. So you're going to select the columns of data, and you're going to select which normality test you're going to perform. 3 different tests for normality: Anderson, Darling, Ryan, Joyner, and Kolmogorov Simov. So the Anderson, Darling is by default will be selected. So there's a subtle difference in each normality test, but usually Anderson Darling is going to be the preferred choice. But your normality, so just basically it's going to give you a graph something like this. You want your p-value to be greater than 0.05. If that represents your data is normally distributed. Support also in your PQ study, so you can see your p greater than 0.05 or 0.05. Depending upon the manufacturing process and depending upon the data, so you can see the information here. After that, you will be starting your process capability analysis. So first is your stability, and second is your normality, and third is your process capability. We are going to be interested in. So assuming that your process scale and data is normally distributed, you're going to do your process capability analysis. So let us potential, and then we will do for process performance study. So to assignment, one of them is going to be doing for process potential and doing for process performance. So let's first look at the process potential study. So potential study, it's all about consecutive samples. I have just taken all these samples. Let's assume that I have taken 100 samples from the production line. Now I'm going to analyze my data here. And you're going to go to stat, quals, capability analysis, normal. Okay, so this is what you're going to be clicking on. And there is also one more option called capability 6-pack. So capability 6-pack is going to give you like other information the control charts and the normality results is also combined into the capability results. So if like this, you'll have a comprehensive information. If it's capability analysis, only you will be getting the capability analysis results. We're doing process potential study. Okay, doing process potential study. So you're going to be doing the first option, single column, because all our results are with a single column. Okay, here we don't care about the sample number or anything. So the only thing we are the only layer is where the data is present, where the measurement results are present. Okay, all my measurement results are in this column, the C1. So I'm just going to click on that and select that column. The thing that is necessary is what is the subgroup size. So since our here is doing process potential, so usually you're not going to have more than one subgroup. So since it is going to be consecutive samples, there is just only one subgroup here. So you're just going to do one. And you want to specify the lower specification and upper specification limit from your customer requirement or from your requirement. And you can also give, there are other options for you to select. So in this case, most of the other things are going to be pretty standard. So leave the other things as such. Okay, selected the respective columns. You're going to click on OK. And right now you are seeing capability analysis graph. So you are seeing the LSL, the USL, seeing the specification limits, your process mean. So earlier someone asked me like the X bar, what does the X bar represent? The X bar is the process mean, and my process mean is, or sample mean is 98.64. This is the X bar, that is what it represents. So if you have targets, you can also include your target value in the settings. So you selected the necessary information from this. So there's options where you can also enter the target value. So if your target is, for example, 98.64 or 98 in this case, you can include that. And it's going to give you the results with respect to the target. So this is the target and this is where your process mean is. USL and LSL is here, and you can clearly see that your specification with respect to the process mean, so it is going outside. So in this case, it is going outside the LSL. So that means your CPK is like not a good value. It's going to be less than 1. So if you look at the CPK value, so you can clearly see that it's less than 1. So basically from the graph itself, you can clearly identify it's not within the specification limit, and it needs need to look at and try to establish what is the root cause of the problem and try to bring the process in a statistical control. Okay, so here you are seeing PPK value, so it will calculate that, but since we are doing potential study, the standard deviation is going to be calculated using the range or the other method which we saw. So using that method, the standard deviation is calculated and you are seeing this value. Okay, just try to play around with this and try to give your own values. Just try to like some values do from 100 or to like 50 samples samples, the more the number, the better your graph will look like. So establish your own specification limit and your target, and try to like play around and try to bring the CPK value greater than 1 and less than 1. So that's going to be like one of your assignments. So you'll be using this process capability. So I want this graph. So one with your CPK greater than 1 and one with your CPK less than 1. Accordingly, modify the data here. And this is how you do your capability analysis. And graph which I talked about, like the capability 6-pack, the other capability analysis graph. So it's going to be the same, except it is going to give you like additional information addition to this histogram here. Let me necessary details here. Process capability 6-pack. So in addition to your capability results, it is giving you the stability result also, the individual moving range chart, so you can bring information in one place. And also it gives you the normality plot also, so it gives you whether your data is normally distributed or not, and your CPK or your CPK value or your PPK value. What I did is I modified the data a little bit for this. So I changed the UL and LSL, and because of that, I got my CPK value greater than 1.78. In my previous case, if you get this information, my USL and LSL was different, and because of that, my process was specification limit. So for this analysis, I just changed the limit and I played with it, and I brought the process in within the specification limit, and because of that I got my CPK value greater than 1 here. Okay, so usually you will be using this process capability 6-pack. So for today's assignment, just use this only one graph. So create your data, go to Stat, Quality Tools, and Process 6-pack normal. Okay, and select the column. Since we are using doing process capability, a process potential study, you're going to be using the first choice, where you're going to be entering all your results are in only one column. Select that, select the subgroup size, which is going to be only 1, and your lower specification limit and upper specification limit. Go to options and select your target. Give your target also if it is required. If not, you don't have to. You will be clicking on OK, and this graph is going to be displayed. You are trying to see out your CPK value here. Okay, that's what the process potential study is about. So you are trying to see whether your process has the potential of meeting the specification for that being in the short run. So for that being in the sense like with minimum number of variations. So just with a couple of like with one production line and an operator and a set of raw materials. With more variations, you are trying to do the study and trying to find out whether your process is feasible or not. The first assignment for today. The first assignment was doing the attribute agreement analysis, creating your attribute data, and to kappa value or percentage agreement greater than 90% or 0.9, and the next study being failing your attribute agreement analysis. And the second study is process potential, which is consecutive samples. Give the results in one column. Go and select the process capability 6-pack, have your specific limits and target, and get a CPK value, in this case pass the result greater than 1 and CPK value less than 1. In assignment, and now we are going to look at is the process performance study, which is multiple subgroups of data. So for a process study, you can use anywhere from 5 subgroups to like 15 or 20. the more the number, the better the results will be. So the accurate information is going to be projected here. So you're seeing in the worksheet, so just with either 10 subgroups or 15 or 20, and for each subgroup you can choose the number of samples you wanted to use. Please use 5, or maximum you can use any number. So minimum 10 subgroups and minimum 5 samples in each subgroup is required. Once you have all the information, the same process here, go to quality tools, capability 6-pack or capability analysis, normal. Instead of using the first column, so you choose the second column, subgroups across rows of. Okay, so you're going to do is, you're going to click on the field and select the subgroups, select the rows that has all the information. So that's the only difference between process potential capability and how to select the data here. We have multiple subgroups of data, and we put the specification limit and the process mean, and click on OK. So look at the information. So we are doing process performance. So instead of individual moving range chart, you will be getting X bar chart. So that is what you are seeing right now. And normality plot is given here. And PPK and your P value is given. So we are doing process performance. So we are going to look at the PPK value. This is what we are going to be like focused on, because in this calculation, it has taken all the samples from all the subgroups of data and has calculated this. You will be getting the PPK value greater than 1 to pass it and less than 1 to find the result. Okay, so going to be the third assignment for today. So use your same process capability 6-pack. Just choose the appropriate, the second. In this case, try to choose the second option for choosing data which is represented in multiple columns, and then do the same analysis, and one passing the capability study and one failing the capability study. Okay, so in this case, in this particular protocol, so this is how you will be doing. So you will be getting the information or data. So we have used only 3 subgroups, I guess. Only 3 subgroups. So subgroup number 1, I have taken 15 samples. In subgroup number 2, I have taken whatever samples, and in subgroup number 3, I have taken 22 samples. Okay, I've got all my results here. So using the results, using mini tab, I plotted the process capability 6-pack. My PPK value to be 2.26, which is very, very good. Most you can see like it's a very, very capable process, and that's how we are going to be doing this respect to your PQ execution. And if you're OQ execution, the same process. Only thing is you're going to be doing CK, like looking at the CPK value, because in your OQ study you are going to be like not inducing more variation. Sometimes you will not be doing any type of capability analysis. So just in your PQ study you're going to be doing the capability analysis and interpreting your results using the PPK value. But again, it's just information. It's going to be something how the company follows their procedure, and all OQ and PQ is going to be having this process capability analysis. Sometimes the process capability analysis will be done outside of your validation protocols. So once your validation activity is completed and once your manufacturing operations have started, so you might want to do a process performance study like 2 months from now or 3 months from now. So just to make sure that how well your process, your manufacturing process is performing and how well the products are meeting the requirement. In those cases also the process and capability analysis will be done, not only in your qualification, in your validation stages, but also once your operations, manufacturing operations have started. Right. So if not, I'm just with the rest of the slides here. Play around with the limits. So for demonstration purpose, I just played around with the limits in order to get a CK value less than 1 or greater than 1. What you're going to be doing is you're going to have set your specification limits, your upper specification and your lower specification limits. So that is fixed. That is not going to be changing at all. You're just going to be changing the information, the sample information, the measurement results. Okay, so by alterating or by changing the measurement results, so play around with the measurement results, and one result you should be getting a CPK of greater than 1, and by changing the other results you'll be getting a CPK less than 1. So do not change the specification limits. So for simpler purpose, for demonstration purpose, for a quicker way to show you the difference, I played around with the specification limit. So usually you will not be playing around with the specification limit. That is always fixed for requirement. Target values to your own. So imagine any product like take a chocolate bar or something. The length of the chocolate bar or the weight of the chocolate bar should be like 100 plus or minus 2 grams. So just 100 is going to be the target. So just imagine a product or use your own information. So you're going to set the upper specification limit and the lower specification limit and the target. It's going to be always fixed. Okay. And what you're going to be doing is playing around with your samples that you're going to be collecting and sharing. So you're having 100 samples, so just change all the values of the samples, like some samples close to the range, some samples away from the specification limit, so that you will get a PPK value less than 1. If your measurement results are going to be like less than the specification limit, then obviously your CPK is going to be less than 1. And try to play around with the next set of data where your all the samples are going to be close to the target or close to the tolerance limit, and you will be getting a good CPK value, in this case greater than 1. Right. Next few slides are just what we saw right now in mini tabs, the individual moving range chart, which is used for your process potential, which is consecutive samples, the XR range chart, which is for process performance, where you're going to use subgroups of data, Normality test and your graphical summary. So basically these are information in order to find out whether your data is normally distributed or not. So I have a local p-value here. So the p-value should be greater than 0.05 for your data to behave normally. And this is not always the true. In some circumstances, it can be less than 0.05 depending upon the application and how critical it is to the quality of the product. And that we discussed is the capability analysis and the capability six-pack. So the capability analysis is going to give you only this capability chart, and the capability six-pack along with the capability analysis, it is going to give you the analytic chart and your control charts which we discussed. Okay, that's the difference between capability analysis and six-pack. And today's assignment, as I mentioned, you're going to be just doing the capability six-pack, one for the process potential and one for the process performance. So in total, I'll be looking at 6 mini files. So 2 for attribute agreement analysis, so 2 for process potential and 2 for process performance. Because each study you're going to be failing and passing each and every information. So I'll be getting like 6 project files, mini project files to look at the data here. If not, I'm going to stop here for today. So we will continue tomorrow, same time at 5. Tomorrow it shouldn't take more than an hour to complete the rest of the slides. And we are going to discuss about the mock interview and the marketing. Okay. So any questions, please feel free to call me or message me if I don't pick up. So I will definitely respond to your text. So that's all I have for today. So any questions, anyone? Let you go. So I just want to take the attendance here. So please attend by Sunday. So when we do our mock interviews, I'll be discussing about your assignments as well. So submit your assignments by Sunday. So that's the remainder here, because our mock interview is going to start from Monday, next Monday. So then accordingly, like look at all your assignments and provide feedback if anything needs to be changed. Here. Hari. So back to your attendance here. So just look at people say do. Thanks everyone. So I will send you the for today and tomorrow, and initial I will send you the recordings as well. So you're not able to download. So I can send you that. And everyone, and we will meet tomorrow at 6 p.m. Ishita, I have marked your attendance. Yep. Yes, I marked everyone, Bishara, Buj, everyone, like I marked your attendance.
Did you get my assignment?
Rohit Raj, yes, I marked your attendance, Rohit.
Yeah, okay, sorry. Thank you.
Yeah. Okay, so send Dhruv, Sulabh, and Ishita, I will send you the links for day 7.